I plan to use a Raspberry Pi Pico W to monitor if there is a problem with my HVAC condensation system. The air handler for my HVAC system is in the attic. It sits over a tray to connect condensation water if the primary tube that removes condensation water from inside the unit becomes clogged. The primary tube is a 3/4 inch PVC pipe with a trap outside. There shouldn't be any water in the tray if water in the PVC pipe is flowing. The tray also has a smaller tube to the outside. There is a float that should disconnect power to the unit if the secondary tube becomes clogged and the water level becomes high enough to raise the float. I would like to know if water is collecting in the tray long before the level gets high enough to disconnect power to the HVAC. The water sensor returns an analog value to the Pico. The Pico analog to digital converter returns a 16-bit value. That is a value from 0 to 65,000 plus. When there is no water in the system, the readings are a few hundred, normally about 300. When the water sensor detects water, the readings become very high. They tend to exceed 10,000. It depends on how deep the water is above the bottom of the sensor. I have a program written to use MQTT to transmit the reading plus the day of the month once a day. If the Pico is restarted, it assumes it's a new day and transmits readings and the day to the MQTT system. I have an app on my cell phone to receive MQTT messages. I have a Raspberry Pi 2 that I use as a private broker. There are online MQTT brokers that are available. Adafruit has one that is free to use. I use Wi-Fi to get the time and date from an internet site. I'll cover these topics when I go over the MicroPython code. I added an LCD display to show the readings for this video. I may disconnect the LCD when I put the system in place. I have soldered headers onto a prototype board to connect the sensor and the liquid crystal display. I also have wired in a reset button onto the prototype board. That saves me the need to continuously unplug and replug in order to restart the Pico when I'm debugging. I also have a blink light. I also blink the onboard LED to let me know if the system is running. Here we have the wiring diagram and the pinouts for the Pico W. Down at the bottom of the wiring diagram is the actual water sensor. The reading from the sensor depends on the level of the water, or how far down into the water the sensor is. The data output from that sensor goes into GPIO pin 26, which is A to D converter 0. The VCC goes to the 3.3 volt outlet from the Pico. And on the right here we have the ground. The liquid crystal display, the VCC gets 5 volts from pin 40. It gets ground from pin 3. The clock is from pin 2 or GPIO 1. The data out, or in rather, comes from pin 1, which is GPIO 0. This is my Raspberry Pi Pico system that I plan to use to detect if there is water in the overflow tray for my HVAC system. This is the Raspberry Pi Pico that I have mounted on a prototype board. This is a little reset button. This unit up here is the water level sensor. And now this is the liquid crystal display. If we start running the Pico, the first thing it does is to log on to the Wi-Fi. After it logs onto the Wi-Fi, it will display a value that's being provided by the water level sensor. You'll notice that it's near 300, and it'll fluctuate a bit around that value. Then when I put the water sensor into water, it'll return a rather high reading. In this case, it's over 28,000. If I increase the level of water on the sensor, you'll notice that the reading will go up depending on how much is in the water. If I reduce the amount of water on the water level sensor, that reading becomes less. And then if I take it out, we start getting readings down in the hundreds again. My water sensing system using the Raspberry Pi Pico W is written in MicroPython. And this is the code that I use for that program. The very first line imports information from a secrets.py file that contains log information for the Wi-Fi. The next few lines import libraries that are available in MicroPython. The next line is needed for the MQTT messaging system. Now that's not built into MicroPython, but if you use the Thony development environment and search for MQTT, this library should show up and you can install it from there. And then it'll be copied onto your Pico. The last library needs to be downloaded from the GitHub website. I have a link to that website below. Now there are two files that need to be downloaded, so when you go to that site, the two files ought to be obvious to you. The next line tells the Pico where the water sensor is connected. In this case, it's connected to the analog digital converter located at GPIO pin 26. I also use the onboard LED I blink it so that I know that the system is running. And this tells the system that I'm using that LED. Now if we skip down to the main code, the first thing it does at this line is to log on to the Wi-Fi. Now if it's successful in logging on, it returns a true value. So below that we look to see if it's connected. If it is, we set the onboard real-time clock value variable as RTC, and then we make a call to a function to get the current time and date and program the real-time clock. So if we take a look at that up here, this is the function that it called. It goes to the website worldtimeapi.org/API/IP, and the website looks to see what your IP address is and returns the time and date in the JSON format for your locality. Now the rest of this program looks at that JSON data, builds an array to program the onboard real-time clock. You'll see that what's programmed into the real-time clock in this array, starting at index 0, is the year, month, day a week, the hour, minutes, seconds, and subseconds. And then we go back to the main code. The next few lines of code set up the MQTT messaging service. I'm using a Raspberry Pi 2 as a MQTT broker. And so I need to tell it where on my LAN that broker is located, and it's located at 192.168.1.195. I use a client ID of water and a client topic of water underscore value. And this line of code sets that up and uses the variable client. Now I only transmit that data to the broker once a day. So what I've done is I've set up a variable called old day equal to 40. Since there are no days of the month 40, every time we log on or boot up and the system looks to see if the current day is equal to the old day, it's not. So it publishes the data. The next line of code is to set up the liquid crystal display. We have it uses an I2C capability of the Pico. There are more than one, and this one is using I2C 0. The data is at GPIO pin 0. And the clock is at GPIO pin 1. We use a frequency of 100,000. The next two lines are are used to set up the liquid crystal display. Now if we go back to our main program, the first thing it does at this point is to read what information the water sensor is sending to the Pico. And it displays that information on the liquid crystal display. Now when I install this, I'll probably not do this here. I'll probably go back down underneath this if statement and read the water sensor instead of doing it as I'm doing now, about every 5 seconds. Before we get to this if statement, I look at the real-time clock and read that into an array called TM. Index 4 of TM is the hour. So this first if statement in this loop looks to see if the current day is equal to the old day. In this case, it says if it's not the old day, so we now have a new day, and it's past 10 in the morning. For some reason, I don't know why I picked 10 in the morning. I just thought it'd be better if it were later in the day, so that I know to look at my telephone to see if I received the message. If it does all that, it sets the old day equal to the new day. I log on to the Wi-Fi again because we don't know if from day to day if we've stayed logged on. And then I go out and get the current time and day again. And you remember when I do that, I also set up the real-time clock, because sometimes real-time clocks don't always keep perfect time. Following that, I build a message that I want to publish to the MQTT. Now the message includes the day of the month, followed with a colon and a space, and then the reading from the water sensor. I connect to the MQTT broker. Then I publish a message. Now this print statement is here for debugging. So that's done for the day. When we fall out of that if statement, you notice I turn the LED on. I leave it on for 0.05 seconds. I turn it off, and then I rest for 5 seconds. And then I go back and continue this loop over and over again. Now notice underneath, when I read this water level sensor, I update the LCD, and this function up here merely writes that information to the liquid crystal display. Now once all this is done, as I said, that information gets published, and what I will get is on my phone, I have an application or an app called MQTT Snooper, and it displays what this program has published. Now in this case, I published a value at 1029, and it read on day 14 it had a value of 272. Then I rebooted. Remember, when you reboot, it always thinks it's a new day, but I rebooted with the sensor in the water, and in this case at 1031 it published a value on day 14 of 29,671. So this is what happens with this program. Every day around 10 o'clock I'll get a message on my phone. I get a notification that I have a message on my system, and I know that there's not a problem unless I get a very high reading.